So now we're going to be looking at this question. You've got A and B are points on the curve. Y equals e to the t. That looks like a t. And t is positive. Okay. Right. Okay. So you've got a curve and 2 points on it. Sure. The tangents at A and B form an angle of 45. Prove that this is 2. And solve this equation to show that e to the t equals 1 plus root 2. So, okay. With that in mind, we've got the curve y equals e to the t, and you've got 2 points A and B. That might, drawing it out may make the question make a little bit more sense. Just make sure whenever you're doing a question, you do whatever you need to do within reasonable time constraints to make sure you understand what's going on. So if you've got y equals e to the t, that would be this curve. You've got 2 points on the curve, and because A is e to the t and B is negative t e to the t, you're told that t is positive. You're told that t is positive. So that means A is somewhere here, and B is somewhere here. And, well, I guess they must be symmetrical about the axis, but those are your 2 points. One is there and one is to the left. The tangents at A and B form an angle of 45 degrees, right? So you basically have some tangent there and some tangent here. And presumably, it doesn't really look like it in this question, in the way I've drawn it, but this is theta, and we're told that's 45 degrees. So prove that e to the t minus 1 over e to the t equals 2. And solve this equation to show that e to the t equals 1 plus root 2. Okay, so I think we're going to have to use this piece of information about these two forming an angle of 45 degrees. Now, that probably technically isn't part of the syllabus anymore, although I think part 2 we can do. But even so, you could, I mean, although the actual dot point is no longer part of the syllabus, you can kind of work it out from the theory you've learned. So so basically we understand that y dash equals e to the t, right? It's an exponential function. The derivative is e to the t. And so y dash at a means we would sub in t. That means it would be e to the t. So this is at a. And y dash at negative t would be e to the negative t at b. And we kind of knew that from our theory anyway, because we know that the exponential curve has a gradient which is equal to itself. And we know what the values are. They've already given it to us. So these are the gradients. So this is the gradient of the tangent at A. This is the gradient of the tangent at B. Now, we know that these two tangents meet at 45 degrees. And there is a formula that we'll just use directly, and it's not part of the syllabus anymore, that tells you the tan of the angle between two lines is equal to the absolute value of m1 minus m2 over 1 plus m1 m2. It's really a difference of tangents, which is it's very similar to your tan alpha minus tan beta formula, which is where it comes from. We won't derive it, we'll just use it directly, and we'll get on to part 2, which is sort of maybe more relevant to you. So we've got, let's just call it e to the t minus e to the negative t all over 1 plus e to the t times e to the negative t. Theta, of course, is 45, so that's 1. E to the t times e to the negative t is 1. So that means we've got absolute value of e to the t minus e to the negative t all over 2 is 1. So very quickly, you can see that means e to the t minus e to the negative t absolute value equals 2. And for t positive, the absolute value of e to the t minus e to the negative t is just itself, because t is positive, and e to the t, therefore e to the t minus e to the negative t is positive. And then you just rewrite it. And that's what they wanted. But it's fair enough to have trouble with part 1 because you don't use that formula in the new syllabus anymore. But otherwise, it's quite okay. Now, you want to solve this equation to show that e to the t equals 1 plus root 2. So did you, I mean, you should be able to do part 2 using part 1. And so remember, in an exam, attempt to do the later parts. Even if you can't do part 1, attempt the later part. And if you want to solve, they even told you to solve the above and show that e to the t equals 1 plus root 2. And I think that's giving a very strong hint, right? Because if you have trouble seeing how to solve that, you're not even solving for t, right? You're solving for e to the t. So if you think of e to the t minus 1 over e to the t equals 2, and you're really solving for this thing, think of it like x, if you like. So x minus 1 over x equals 2. Hopefully that makes it more obvious. You can just multiply everything by x, so to speak. Which means, of course, that x squared minus 2x minus 1 equals 0. And then you can use the quadratic equation. I mean, 4 plus 4 is 8, which is 2 root 2. I guess the thing you now need to worry about is what x actually was. X was e to the t. Well, I mean, we've got two options. It could either be 1 plus root 2 or 1 minus root 2. But the thing is this, e to the t is, well, is an exponential. And you know an exponential is always positive. Now, 1 minus root 2 is not positive, right? It's going to be negative 0.414 or so, whereas 1 plus root 2 is. So because this is negative, you would then say, therefore, e to the t equals 1 plus root 2 only. And that is how you do that question.